All right. Good morning or good afternoon, depending on what time you're watching this video. Today we're going to talk about common logarithms. So, sounds kind of fancy or whatever, but I'm going to show you how to solve an exponential equation where your bases are not the same, and then I'll show you how to make sure you enter your equation into Desmos correctly, so you can get the correct decimal approximation. So let's start with something we know we can do. So if I saw this particular problem right here, 3 to the 4x plus 1 is equal to 27 to the x minus 5. So if I saw this problem, I can make these be the same base. I can make 27 be a base of 3. So I would bring this over, and I would change 27 to 3 to the third x minus 5. So that's something that we know how to do. Then from here, and I'm actually going to switch to my black pen just so we can see a little bit better. So this is 3 to the 4x plus 1 equals 3 to the third. I made those be the same bases, x minus 5. So my bases are going to cancel, and we'd be left with 4x plus 1. Make sure to do the distributive property over here. So that would give me 3x minus 15. So this is what we did last week. Make them be the same base, bases cancel, etc., etc. We solved the equation. So what would happen if I saw a problem where the bases were not the same, like this problem down here? So what about 3 to the x equals 15? You cannot change 15 to be a base of 3 because 3 to the first power is 3. 3 squared is 9, and 3 to the third is 27. So we've already passed 15, and we're not going to get into decimals and things like that. So what would we do? So I'm going to show you how to take the log of both sides and then go through and solve your equation that way. I'll show you how to get the exact answer and then how to get a decimal approximation. So just a few things to jot down. Make sure you pause it, of course, if you need to. So just some reminders. Base 10 logarithms are called common logarithms. So if you see log by itself, the understood subscript is the number 10. That's what the log base means. So if you just see, so that's what I just said right there. So if you just see LOX by itself, the understood base, the subscript is the number 10. If both sides of an exponential equation cannot be easily written as powers of the same base, you can solve by taking the logarithm of each side. So that is what I'm going to show you how to do right now. So again, if you're not finished writing that down, the manager of television, you can pause. So let's jump to a problem. Let's take a look at number 1. So this is the one that I got a little question mark up there by. So 3 to the x is equal to 15. So how would we solve this problem? The first thing we want to do is recognize that we cannot take the same base. So when you cannot take the same base, you're going to take the log of both sides. So I'm going to take the log of this side, so log, and I'm going to take the log of the right-hand side. So we know in math by now what you do to one side, you do to the other side. So I took the log of both sides, and you only do that when your bases are not the same. Now we're going to use our properties of logarithms that we talked about yesterday. This x is an exponent. So the third property that we talked about yesterday says if you have an exponent, you can make it be a coefficient in the front. And if you have a coefficient in the front, you can pop it up and make it be an exponent. So we're going to use property number 3 from yesterday. So now I can rewrite this problem as x log 3 is equal to log 15. All right, so far so good. So we're making our way through. Now, the only thing we have left to do is to get x by itself. So no different than all the other types of equations we've studied this semester. We're trying to get x by itself. So this is x times log 3. So if we just divide both sides by log 3, so divide by log 3, these logs are going to cancel. And my final answer is x equals log 15 divided by log 3. So that is our final answer. We started this problem. We could not have our bases, or we couldn't make our bases be the same. So we had to go through and get the log of both sides. Now, log 15 divided by log 3, we can type that in Desmos and get a decimal approximation. So here is Desmos here. Let me get rid of this. So functions, so you can find you can just type in log if you want to, but you do have a, underneath functions, you do have your log thing over here. So I'm going to type in log of 15 divided by log of 3. And you don't technically need a double parentheses that I have there, but there we have it. So this is my answer. So let's see. Let me squeeze this over. So in Desmos, I typed in log base 15 divided by log 3. And our answer is 2.46. So let's round to the nearest hundredth. So to the nearest hundredth, we got 2.46. Now, depending on your answer choices, if your answer choices want the exact answer, then you would keep it as log 15 divided by log 3. If your answer choices were in decimal form, then you would give them the decimal approximation. I do want to make sure to write a note, and I'm going to put this in red because I want to make sure that you do not make this mistake. You cannot do 15 divided by 3. So this is not log 5. So this is not log 5. You cannot do the log of 15 and reduce it to the log of 3. Logarithms do not work that way. So this is not the log of 5. Notice when I do 15 divided by 3, if you did think that you can simplify it, notice I got 2 different decimal answers. So you cannot divide these logs. So your answer is either log 15 divided by log 3 as the exact answer, or as an approximation rounded, it is 2.46. All right, let's try some more. Number 2. I cannot make these two numbers be the same. 42 is not a power of 6, so I cannot make these be the same. So we're going to take the log of both sides, and I'm going to take the log of this side. Again, I can use my properties of logarithms that we studied yesterday. This x is an exponent. I can drop it down in front. So that's a legal math move that we can make. And this is x times the log of 6. So divide both sides, and we get x equals log of 42 divided by the log of 6. So the log of 42 divided by the log of 6. Again, I'm going to put this in red. This is not the log of 7. So do not simplify your logarithms. It does not work that way. Unfortunately, the people that make up the test and things like that, they will have log of 7 as an answer choice. Do not fall for it. That is not correct. So we'll come over to Desmos and we'll type this in. So we're typing in the log of 42 divided by the log of 6. So I'm just going to use this one here since it's already there. Log of 42 divided by log of 6, and ta-da, and we're round, so it'll be 2.09. So in decimal form, this is approximately, if I round to the nearest hundredth, 2.09. So again, this is your exact answer, depending on what the problem is looking for. That's my exact answer. And then this is my decimal approximation. Okay, I'm going to show you one more to make sure we got the hang of it there. So I'm going to show you one more. And so that was my exact answer and then approximation. And the same thing up here, exact answer and then approximation. Okay. Last but not least, number 3. I cannot make 12 be a base of 4. 4 times 3 is 12 true, but that's not a power. It's not a base of 4. It's not 4 to the second power or 4 to the third power. So this time I'm going to take the log of both sides. Log of 4 to the 3x is equal to log of 12. Now that 3x, that whole exponent, whatever your exponent is, that whole thing is going to come down. So 3x log 4 is equal to log 12. All right, we're trying to get x by itself, so we're still going to carry on. This is 3x times the log of 4. So we're going to divide both sides by the log of 4. So we're going to divide this side by the log of 4, and I'm going to divide this side by the log of 4. The log 4's canceled, so now we have 3x equals log 12 divided by log 4. And the very last thing that we have to do, I still got one more step. We're trying to get x by itself. So not 3x by itself, but we're trying to get x by itself. So the opposite of multiplying, we're going to divide. And we're going to have a somewhat strange answer, but I don't want you to be intimidated by it because we went through and we did our steps correctly. So log base 12 divided by log base 4, and that whole thing is going to get divided by 3. So log base 12 divided by log base 4, and that whole thing is going to get divided by 3. So when we type that in decimals, you can do it in 2 steps or 1 step, whatever makes you feel more comfortable. If you want to do it in 2 steps so that you don't accidentally type something in wrong, there's nothing wrong with that. So log base 12 divided by log base 4, and this whole entire thing is being divided by 3. So I got 0.59, and we've been rounding to the nearest hundredth. So to stay consistent, it's going to be 0.60. Since we've been rounding to the nearest hundredth. So be careful when you type this in decimals. Make sure the log base 12 divided by log 4, make sure that whole thing is being divided by 3 when you type it in. All right, so this has been on logarithms. If you have different bases, you're going to take the log of both sides.